Hello, this is video number 2 on analyzing the graph on photoelectric effect. So let's look at this graph. In this graph we have this y-intercept. We have this y-intercept, we have this x-intercept, we have this x-intercept, we have this x-intercept. Okay. Then if we can look on the y-axis, we have the maximum kinetic energy on the y-axis, meaning that the y-axis, the y is equal to Ek max, that is the maximum kinetic energy. Then on the x-axis we have the frequency, meaning that x is equal to the frequency, x is equal to the frequency, that is f. Okay, now we will remember that we have the equation of a straight line. Y is equal to mx plus c. Nalena is a straight line, y is equal to mx plus c. Same applies with this one, y is equal to mx plus c. You must remember that m is a slope, it's a slope or it's a gradient. M represents the gradient, then c represents the y-intercept. C, y-intercept. Meaning that this negative x is our c for the potassium. Okay, so the formula that we use on photoelectric effect is E is equal to work function plus Ek max. Now if you can look here, we have this formula y is equal to mx plus c. Then on the y-axis we have what? Ek max, meaning that Ek max is the subject of the formula, Ek max. If we want Ek max to be the subject of the formula, this one must be transposed to the energy. So no E minus the work function. So on the x-axis we have the frequency, which means we need to change this one to a frequency. So we have Ek max, which is equal to hf, because E is equal to hf. E is also equal to hc over lambda, but we'll take this one because on the x-axis we have a frequency minus the work function, okay. Now if you can look here, we have this one which represents y, then this is equal to, then this one is x, then this one is m, meaning that the h, which is the Planck's constant, is represented by the gradient minus the work function, or it's plus c. So the negative work function is our c. The negative work function is our c, meaning that c will always be equal to the negative work function in this graph. Okay, now let's go to the questions. Then the gradient m is your Planck's constant. The first question says name the physical quantity represented by x. So x is c, whereas c, we said c is the negative work function, which means x represents the work function. Name the physical quantity represented by the slope. So the slope is a gradient we already said the gradient is the Planck's constant. H, that is the Planck's constant. Okay, then the last question that I have here, calculate the work function of platinum. So we are going to look at platinum now. What we have for platinum, this is platinum. Then we have this value. We need to know this value only on platinum. So that value represents the frequency. So if this one is 0.5, this one it's half of 0.5, so 0.5 divided by 2 is 0.25. So here it's 0.25. So 0.25 plus 1, okay, 0.25. So we have 0.5 plus this 0.5 plus 0.25 to get this one, 0.25. Then we get 0.75. 1, 0 plus 0.25. 1, 0 plus 0.25, it's 1.25. Here it's 1.25. 1.5 plus 0.25, 1.5 plus 0.25, then here we have 1.75. Okay, then this is the frequency in times 10 to the power 15 hertz, which means we have a frequency which is equal to 1.75 times 10 to the power 15 hertz. This is our frequency. Then we are looking for the work function. This is our frequency. And what is the kinetic energy here? What is the kinetic energy here? The kinetic energy in this line is equal to 0. The kinetic energy there is equal to 0. That is EK max. In that area is equal to 0 joules. Therefore, we use this formula. E is equal to the work function plus EK max. Okay, then this one is the energy. You will remember that energy is also equal to HF, which means this one is HF. H is constant 6.63 times 10 to the power negative 34 times the frequency that we have there is 1.75 times 10 to the power 15 plus EK max. The EK max is equal to 0. Oh no, is equal to, not plus, is equal to, let's substitute, is equal to the work function is what we're looking for, plus the EK max is equal to 0. Therefore, the work function will be equal to, let's press calculator here. Press the calculator, then we get the answer. So the answer is 116.025 times 10 to the power minus 20 joules. Then the question is answered. Okay, then we are done. Thank you. Please subscribe for the next videos.